Hi, I'm Raymond Hunter, and today we're going to talk about the difference quotient. And the reason I decided to do this video is recently somebody reached out, he's in college algebra, and he said, look, I'm really struggling with the difference quotient. I can't get these problems right. There's got to be a way to know how to do these things. So if you are struggling, you're not the only one. Let me give you a little background on the difference quotient. They are part of the definition of a derivative, and the derivative pretty much dominates the first half of calculus. So it's a pretty important part. It used to be years ago, the first time students were exposed to the difference quotient was in calculus, and they struggled with them. So educators then thought, well, let's first introduce them in pre-cal, and then when students get to calculus, they'll be in great shape. Well, that didn't work out so good. So then educators said, well, let's bring it down another year. Let's introduce in Algebra 2. So students have had them in Algebra 2, then pre-cal, and then calculus, and they'll be in great shape. Well, they're still hard for students. So if my point to telling you this is that if you are struggling with these, you're not alone. The part that I see students really struggling with is understanding what to insert where. So I have some tricks for you on how to do this. So let's roll. We're given that f of x is x squared plus 1. So everywhere you see an x on the right side of the equation, put parentheses around it. So even if you have an x just sitting there by itself, put parentheses around it. The next step after that is everywhere you see a set of parens with just an x sitting in them, remove the x. So you have a blank area between the parens. That blank area, that lets you know where to insert things. So if I insert a green dot in the parens on the left, well, I insert a green dot in the parens on the right. If I put a 2 in on the left, well, then I put a 2 in on the right, so 2, 2. If I put in a negative 3 on the left, I put in a negative 3 on the right, so negative 3, negative 3. If I put the letter A in on the left, well, then I put the letter A in on the right, so AA. If I put x plus h in on the left, well, then I put an x plus h in on the right, so x plus h, x plus h. So here we have it. F of x plus h is equal to x plus h quantity squared plus 1. And as you can see, we will need that for the difference quotient. It's up there in the numerator. So the next step is to tackle the difference quotient. Put grouping symbols around the f of x plus h and the f of x. I'd use square brackets. These grouping symbols serve two purposes. First, it makes it much easier to see what to insert where. And the second thing is it prevents you from losing that minus sign between the two terms in the numerators. We know that f of x plus h is x plus h quantity squared plus 1 because we just found that. And we're given that f of x is x squared plus 1. So in the numerator where you see f of x plus h, just remove that and put in x plus h quantity squared plus 1. On the right side of the numerator where you see f of x, just remove that and put in x squared plus 1. At this point, the difference quotient is set up and it's done. The rest of the problem is just simplifying. But we're going to go through that. So first thing I'm going to do is I'm going to FOIL the part, the x plus h. When I do that, I get x squared plus 2xh plus x squared. And I very carefully, I didn't deal with that minus sign yet because I want to take a separate step to do that one by itself so I don't make a careless error. So now in the next step, I'm going to distribute that minus sign to the x squared and the plus 1. And you can see that I've done that. So at this point, there's no reason for any of the grouping symbols. The parentheses and the square brackets can go. And so the next step down, all I did was remove the grouping symbols. And at this point, we're going to combine like terms. And this is an important tip for you. Anything that doesn't have an h in it should cancel. So the x squared and the minus x squared cancel. The plus 1, the minus 1, they cancel. And the only terms left over have an h in them. So I have a 2xh plus an h squared. If you have terms left in the numerator that don't have an h in them, then you did something wrong and you got to go back and take a look at it. The next step is to factor an h out of the numerator so that you can reduce it with the h in the denominator. And what's left over? 2x plus h, and that's your answer.